Good day, students. Good day, students. I hope everybody is doing great. Today, our main strands here is geometry and measurement. Our substrands is measurement. Under the measurement, you are going to talk about the triangles and properties of some quadrilateral shapes. Our lessons have been taken from the new curriculum of BS5. Strands number 3, substrand 1, content standard 1, indicators 2, and then you continue from indicators 2 here to indicator 3. So we are going to use the two indicators to talk about the triangles and some properties of quadrilateral shapes. When you talk about triangles here is a plane figure with 3 sides and 3 angles. Now, triangle is a plane figure with 3 sides and 3 angles. So when you have a plane figure which has 3 sides and 3 angles, we call it triangle. Let's see the type of triangle that you're going to talk about under this indicator. Type of triangles. Today we will talk about equilateral triangle, right angle triangle, isosceles triangle, and scalene triangle. Now we are going to take them one after the other. We will first talk about equilateral triangle. Equilateral triangle here derive the word from the equal size or equal angles. So this type of triangle has all the 3 sizes equal and the 3 angles equal. Now these are the indicators that shows. So that is the examples or a diagram that shows what equilateral triangle. It has the same indicator mark here, which shows that the 3 lines here are the same. This line and this line and this line are the same. So a type of triangles that has 3 marks equal and 3 angles equal. If here is 60 degree, then here too must also be 60 degree, and here too must also be what, 60 degree. And a triangle, the internal angles must sum up to 180. So all the internal 3 angles, when you sum them up, you're supposed to get 180 degree. So equilateral triangle is a type of triangle in which all the 3 sizes are the same. And once the 3 sizes are the same, the 3 angles are also what? The same. Good. Now, let's talk about other triangles here. Isosceles triangle. You have done with equilateral triangle. We said equilateral triangle is a type of triangle in which all the 3 sizes are the same and 3 angles are also what? The same. Equilateral, equal angles, equal sizes. Now we are going to talk about another type of triangle, which is also isosceles. Isosceles triangle here. This is a type of triangle which has what? 2 opposite sides equal and 2 base angles equal or congruent. So when you have this type of triangle here, the 2 opposite sides here, this line and this line are opposite. So the 2 opposite sides are equal. And once the 2 lines are the same, their base angles must also be the same. They are equal. That is why if here is angle A then here must also be what? Angle A. Because those lines that form the angle A are also what? The same. They are congruent and they are equal. When you say something is congruent, it means they are the same or equal. So that is isosceles. The two sizes are equal and two base angles are also what? The same. So the internal angles here, the two angles are always the same, and only one angle will be different from the two angles. That is isosceles triangle. When you talk about right angle triangle, this triangle has one of its angles equal to right angle or 90 degree. When you say right angle, it means 90 degree. And this is a symbol that we normally use to represent the 90 degree. So any type of triangle in which they are formed by two perpendicular lines here, the vertical and the horizontal, the angle that form at their point here is what? 90 degree or right angle. Because one of its angle is equal to right angle or equal to 90 degree. Therefore, this type of triangle is called right angle triangle. Now, the last type of triangle that we will discuss is scaling triangle. Scaling triangle. This type of triangle has three different sizes and three different angles. Now, looking at this one here, you could see that the lines that form the triangles are three. We have the three line segment, one is here, one is here, and one is here. The lines indicators or the marks on the line shows quietly that those lines are not the same. Here it has only one mark, two marks, and three marks, which means the lines that form these triangles are not the same. It has three different sizes. Once it has three different sizes, the internal angles here are also different. A, B, and C. That is three different sizes and three angles. So these are the type of triangles that we talk about. We discuss the equilateral triangle in which all the three sizes and three angles are the same. And then we have talked about isosceles. It has two opposite sides equal or two sides equal, and its two base angles are also equal. We have also talked about right angle triangle because of one of its angle is equal to right angle, or one of its angle or one of its internal angle or the interior angle is equal to 90 degree. That is why we call it right angle triangle. Then the last one that we have talked about here is scaling triangle. This type of triangle has three different sizes and three different angles. The size here are what? Different, and the angles are also what? Different. Okay, good. Now let's talk about quadrilateral. Quadrilateral is a shape with four sides. So quadrilateral shape here is a shape with what? Four sides. So all those shapes with four sides are called quadrilateral. And then a shape with three sides, we said they are called triangle. The quad means four. And here the interior angles of quadrilateral, when you add them, you must get the 360 degree. The triangle, the interior angles, all the three interior angles are summed up to 180 degree. But the quadrilateral, because the sizes are four, the interior angles, when you sum up, you must be able to get 360 degrees Celsius. Now let's see the type of quadrilateral shapes. We have square. Square, it has 4 sides. We have a rectangle. A rectangle also has what? 4 sides. And then rhombus, parallelogram, trapezoid, or trapezium. Then these are the quadrilaterals that we are going to discuss. It says square, rectangles, rhombus, parallelograms, trapezoid, or trapezium. We will demonstrate the understanding of the properties of using the sides, angles, and diagonals of quadrilateral shapes. So we are going to use the sizes to compare, or the angles to compare, and their diagonals to draw the lines between the listed quadrilaterals here. Now, the first one that we talk about here is square. Square is a quadrilateral because it has 4 sides. And aside having 4 sides, all the 4 sizes are the same. Now, let's look at the diagram here. All the 4 sides are equal or congruent in length. Now, looking at this one, it has 4 sizes here. The marks on the 4 sizes are 2, 2, 2, 2, which shows that the lines that form a square here are the same. All the sizes are equal. Then the opposite sides are parallel. Now, when you say the 2 lines are parallel, it means when you extend to their direction, they will never even meet, okay? So these 2 lines here and these 2 lines here, when they move in the same distance, they will never meet anywhere. So the opposite lines here are parallel. When you draw this one to end and you draw this one in the horizontal way, they will never even meet. The same thing to these lines and this line here. The vertical opposite lines here are also parallel because the distance between them are the same. They will never even meet. That is why they have the same indicator showing that this line here and this line here are also parallel. They will never meet. All the 4 interior angles are right angles, that is 90 degrees. Now looking at the angles at the joints, all the 4 interior angles here are 90 degrees Celsius because they are formed by 2 straight lines. That is why they form 90 degrees at their corners. So that is another properties of a square. Opposite interior angles are equal and congruent. The opposite interior angles, since all the 4 sizes or all the 4 angles are 90 degrees, then the opposite angles here is 90, here is 90, here is also 90, here is also 90. So the opposite angles are also what? Equal. Then the diagonals of square bisect each into 2 equal parts. Now let's take the diagonal of this square here. The diagonals are the lines that have been slided or drawn to the other side here. Okay, so when you see this line, that is a diagonal line. We have another diagonal line here. It bisects the square into 2 equal parts. When you draw this diagonal here, the size here and the size here are the same, okay? And the angle that's suspended on the diagonal is also 90 degrees. So the size here and the size here are the same. That is why the diagonal bisects into 2 equal parts, okay? This angle and this angle are also what? The same. The same thing, this side and this side are also what? The same. And the opposite are also the same. And here the opposite are also what? The same. So the diagonal bisects the square into two equal parts. One, a square, all the four sizes are equal or congruent in length. Congruent in length means they are the same. It has the same indicator, shows that they're equal size, equal angles, and the diagonal bisect each other. All the four interior angles are right angle. Now the angles at each corner here is right angles here. Good. Now let's talk sorry. Let's talk about other quadrilateral here. We have a rectangle. Sorry. A rectangle here is also a quadrilateral because it has four sides. And let's see all the four sides here. All the four sides are not equal. Now, per the rectangle that I have it before you, all the four sizes are not what? Equal, but the opposite lines or the opposite sides are the same. That is why this line have two indicators. This line also have two indicators, meaning that the two opposite lines here are the same. And then when you come to the vertical opposite lines, they are also what? The same. They have one indicator, shows that this line and this line is also what? The same. Though it has four sizes, but not all the four sizes are the same. The two opposite sides are the same. Okay, good. Then all the four interior angles are right angles because they are also formed by two straight lines, two perpendicular lines, the vertical and the horizontal line. So the angles here is 90-degree. The angles here is right angle or 90-degree. So the interior angles are all 90-degree. Okay. The opposite interior angles are equal or congruent. The opposite, since here is 90, here is 90, the angles are what? The same. Here is 90, here is 90, the angles are also what? The same. So the opposite interior angles are also the same, though all the sizes are not the same, but since they are formed by two perpendicular lines, therefore the angle that form at the joints are also 90-degree. It has two opposite sides equal. That is why the vertical lines are the same and then horizontal lines are the same, but all the sizes or all the lines are not what? The same. Now the diagonals of a rectangle do not bisect each into two equal parts. When you have the two diagonals on the rectangle, you can easily compare this size of what? Triangles and this size of triangles here. They are not the same, okay? So the diagonal cannot bisect the rectangles into two. Here they form two triangles here. You have one here, one here. And when you compare this and that, the triangles here and here are not the same. Are you okay? So the diagonals are not bisect each. Even when you compare this side and this side, here is quite different from this side. Okay, so the diagonal here does not even bisect the rectangles into two equal parts. Okay, the opposite interior angles are equal. The opposite, we said it, they are equal. And then all the four interior angles are right angles, and that is here. And then the opposite lines are also parallel because when you extend this one to another directions and you extend this one to the same direction within the same distance, these two lines here will never even meet. Okay, the same thing applies to the vertical lines. The vertical lines are two perpendicular lines here, so they will never also meet. When you extend upwards, they will never meet anywhere. So the two opposite lines are parallel. Okay, good. Now we are going to talk about rhombus. It has four sides. That is why it's also called what? Quadrilateral, because quad means four. So once it has four sides, then we call it quadrilateral. And this one is rhombus. Rhombus, all the four sides are equal and congruent. Now looking at the rhombus here, more or less it looks like a square, but just that it has a slanted size here. Now the size, it has the same indicator showing that the lines here and the lines here are all the same. So all the four sizes of rhombus are also what? The same. Okay, the opposite sides are parallel. Now when you extend this line and you extend this line here, the horizontal lines, the two horizontal lines will never even meet when you extend to their or extend to another directions. This line will never even meet with this line. That is why the opposite lines here are parallel. Now, though the other side here that has been slided, you might think it has been slided, but they have been slided in the same angle. So here, when you extend to here and you extend this one to another direction, say they will also not what going to meet somewhere. They will never even meet. So the size here and size here will be extended to the same distance, but they will never even meet. Though they are being straddled, but they will never even meet. So the opposite sides are always parallel. The two opposite sides here too are also parallel. Then the diagonal of rhombus bisect each into two equal parts. Now let's say something here. When you draw two diagonals here, the angles here and the angles here are the same. So the diagonal bisects the rhombus into two equal parts. Even when you compare this and that, the angles here and the angles here are also the same. The angles here and the angles here also are the same. So the diagonal bisect each, and the angle that's suspended on their diagonal is also 90 degrees. The opposite angles are also what they say. The opposite angles are also the same. Good. Now we are going to talk about parallelogram. Now, when you say parallelogram here, all the four sizes are not equal. All the four sizes are not equal. Now, looking at the parallelogram here, all the four sizes are not equal because it looks like a rectangle, okay? But this type, it has been slided. So just as similar to a rectangle whereby the other two opposite sides have been what? Slided, okay? So you can use the properties of a rectangle, but just that the interior angles are not 90-degree here, okay? Good, but the two opposite angles are the same. Now let's talk about the parallelogram here. Now the two opposite sides are the same. That is why this one is having 3 marks on the line, 3 marks here, and here 4 marks here, 4 marks here, which shows that the two opposite lines are the same. Okay, and then the two opposite lines are also parallel lines. They will never even meet. Okay, though it has been slided just like the rhombus, it has been slided, but when you extend to what, to the same distance, they will never even meet somewhere. Good. And the opposite angles are also what, the same. That is why this one is having two indicators, showing that it has the two angles here, two angles. Therefore, the opposite angles are the same. Here, the angles here and the angles here are also what, equal. They are the same. Are you okay? Good. The diagonal of parallelogram do not bisect each into two equal, the diagonals. So when you have the two diagonals here, the angle that form here and here are not the same. The same thing applies to this side and this side. The diagonal bisect into two equal parts. No, it does not, because the triangle that form here and here are not the same. Even when you compare this and that, they are not the same. Here and that, are not what? The same. Okay. It's also called quadrilateral because it has four sides, but not all the four sides are the same. The two opposite sides are the same. The two opposite sides are parallel. The interior angles, the opposite interior angles are also equal. Okay, good. Now let's talk about the last one of quadrilateral. Now we are going to talk about the trapezium or trapezoid. All the four sides are not equal, though it has four sides here, which is also called what? Quadrilateral. And here, all the four sizes, it's obviously that you can see that the four sizes are not equal. All the four sizes are not equal. One pair of the opposite sides are parallel. Only one pair of the opposite sides are parallel here. Now you can see clearly that only the horizontal lines are parallel. Here and here will definitely meet somewhere. So those lines that have been slided here are not parallel, okay? They will meet somewhere. When you extend them with the same direction, they will also meet somewhere, okay? But the horizontal lines here, the top line and the what? The baseline here are parallel, okay? They will never even meet, okay? They are the two perpendicular lines, that is the two horizontal lines, they will never meet. But the other opposite lines here, when you extend them upwards, they will definitely meet somewhere here. So this side and this side are not parallel, okay? Good. And then only base angles are equal or congruent. So here the base angles that form here are congruent, but not all the interior angles are equal. The opposite angles are not the same. The opposite angles here are not the same. The diagonals of what? Trapezium or trapezoid do not even bisect the trapezium into two equal parts, okay? Even here, when you compare the angles, the shape here and the shape here, they are not even the same. The shape here, when you compare this and that, they are not the same. So the diagonals of trapezium do not bisect into two equal parts. Only base angles are equal. All the four interior angles are not equal. All the four interior, the angle that will form here, here are not equal. Another pair of other opposite sides are not parallel. Here and here, the other pair of opposite sides, this side and this side, those that have been slided are not parallel, but one pair of opposite sides are parallel. So this one pair here, here the top line and the down lines are parallel. They will never meet, but the other pairs will meet, okay? And that is that. Now, we are going to demonstrate the demonstrating an understanding of the what? Properties. Once we have discussed the properties, now we are going to compare them using the shapes here or the table here to draw one or two things here. Now we talk about the size. We have talked about the angles and we have talked about the diagonals. So per this one, let's see the properties. The properties here, we are taking the size. Rectangle, square, rhombus, trapezoid, and parallelograms. Now we are going to talk about this one. Now let me move a pencil. Now with this, we said when you are talking about the size, the size all sides are congruent. It means all sides are the same. Now let's compare. The rectangle, no, that is why automatically they have no here. The square, all the sizes are the same. The rhombus, all the sizes are the same. So this time I'm going to use Y to represent yes and N to represent no. The rhombus, all the sizes are the same. Good. The trapezium, all the sizes are not the same. No. The parallelogram, all the sizes are not the same. No. Good. Now, the opposite sides are congruent. The opposite sides are equal. Let's talk about the rectangle. Yes, the opposite side. We said the two opposite sides are the same. So here, yes, the opposite sides are equal. Here, yes, the opposite sides are equal. Yes, the opposite sides are equal. The trapezium, only the other side. So not all the opposite sides are the same, but once they have the other side equal, then you can say yes and no, because the other side is equal. The other pair of opposite sides are not what? Equal, okay? The parallelogram, the opposite sides are the same. Yes, okay, good. Now, the opposite sides are parallel. Now, let's talk about the opposite. Yes, the trapezium. Let me do one more cleaning here. The parallel, that is where we have the yes and no. Yes, okay, good. So here the opposite sides are congruent. No, the trapezium is no, because the opposite sides are not the same. But when you talk about the opposite sides are parallel, then that we have the yes and no, because the other two pair are the same. So here is supposed to be the yes and no. Now let me start. The opposite sides are parallel. Yes, because once the opposite sides are the same, they must also be parallel. So once here is also yes, here is also yes, and here is also yes. Okay, the opposite sides are parallel. They will never even meet. Here, only one pair is parallel, the other pair is not parallel. Good. Now we have done with the sizes of the shapes that we talk about. Now we are going to talk about the angles. The opposite angles are congruent. Yes, here we said yes because all the interior angles are 90 degrees. So the opposite angles here too, yes. Rhombus, the opposite angles are the same. The trapezium, no, the opposite sides are not the same. Parallelogram, the opposite sides are the same, or the opposite angles are the same. All the angles are right angle. Here, yes, all the angles, because the lines are straight. They are formed by two perpendicular lines, horizontal and the verticals. So the angle formed at the corner at the right angle is what? 90 degree. All the angles are right angle, which is 90 degree. Yes, here too, yes. Here, no, the angles are not 90 degree because it has been slided, though the opposite angles are the same. Yes. So here the angles are not 90. Now the trapezium, no. Here, no. Okay, good. So the 90 degrees are formed by two perpendicular lines, two straight lines, vertical and what? The rhombus, it has been slided, so the angular form there are not 90 degrees. Though the opposite angles are the same. Then let's talk about the diagonal lines. Diagonal bisect each other When you talk about the rectangle, no, the diagonals of rectangle does not even bisect each other. The square, yes, the diagonal bisect each other. When you talk about the rhombus, yes, the diagonal bisect each other. Trapezoid, no. Parallelogram, yes, no. The diagonal, it looks like a rectangle that have been slided. So here, the diagonal does not even bisect each other. So here is no. Okay. The diagonals are congruent, where even here, it does not even bisect. So how can it be congruent or equal? Here, no. Okay. They are not congruent. Now looking at this one too, yes, when it bisects, the opposite sides or the angles formed in or triangle formed within the quadrilaterals are what? Congruent or equal. So the diagonals are equal. The rhombus too, yes, the diagonals are equal. Here, no. The trapezoid, no. Parallelogram, no. Okay, good. Diagonals meet at right angles. Here, once it cannot even bisect, can never meet at right angle. No. Here is yes, the diagonal meet at right angle, 90 degree. Then here, yes, the diagonal meet at right angle, 90 degree. Here, no. Here, no. Okay, because already no, the diagonal cannot even bisect the parallelogram, trapezoid, and then a rectangle. Okay, so the other associate property here will be no, no, no. Okay, good. Now let's move on to the next one. Now let me clear my table here. Good. Now I think this one will be the last lesson that we are going to talk about is polygons. So when you talk about a polygon is a plane figure bounded by straight edges. So a plane figure bounded by straight edges. So which means the polygons, all the sizes are the same, okay? Bounded by straight edges. Now, let's see this one here. The names associated with the polygons. So polygon and number of sizes. A polygon in which the sizes are 5, we call it pentagon. So a plane shape with 5 equal sizes are called pentagons. A polygon in which the sizes are 6, we call it hexagon. So a plane figure in which all the equal 6 sizes here are called what? Hexagon. A polygon in which all the equal sizes are 7, we call it heptagon. So a plane shape with 7 equal sizes are called heptagon. Then a polygon in which all the 8 sizes equal are called octagon. So a plane shape or a plane figure with 8 equal sizes are called octagon. Then a polygon with 9 sides is also called nonagon. Nonagon. Then a polygon with 10 sides are also 10 equal sides, okay? 10 equal sides, also called what? Decagon. A polygon with 11 sides is also called under decagon, and then a polygon with 12 sides is also called what? Duodecagon. So that is a polygon for you. So you can also say a polygon with 3 sides that is bounded by not all the sizes of the 3 sides. We call it triangle, but we have the type of triangle, okay? So a plane shape with 3 sides, we call it triangle. A plane shape with 4 sides, we call it what? Quadrilateral. Okay. Then the 5 is pentagon. We have the 6 hexagon, 7 heptagon, 8 octagon, 9 nonagon, 10 decagon, 11 and the decagon, and then 12 is duodecagon. Okay. So thank you for watching.